Hi, this is the last video I've made on trig equations. What you will find sometimes in an exam is they make it a real life context question as well, and they're very limited to what they can do. What they're looking for examples of things that go up and down, like a Ferris wheel, although it goes round and round, it is effectively going up then down and then up then down again. They talk about the tide. So you'll see from my questions, there's ones about a Ferris wheel, a wind turbine, tide in the water and a lift. So the best way to do it is just throw you in and let's look at them. This video is a bit different. I'm just going to literally talk through lots of past paper questions that I've found. There is an awful lot of writing involved in them as well, but we'll see how we go. So let's look at this. So this example here talks about a Ferris wheel, and it says that the height of the wheel above the ground is given by that formula there. T stands for your time in seconds. That's important to be aware of. Now, a lot of pupils, they see this in the exam and they just switch off and go, oh, I have no idea what's going on. But it's really just substitution. Usually part A is a substitution and part B is solving trig equations like we have been doing. So if we look at part A, it says find the height of the carriage above the ground after 10 seconds. And then I would say to you, well, what in this formula here stands for seconds? And they would say, oh, T is your time, so 10 seconds. So all you're doing for part A is you're subbing in T equals 10. So you're letting T equal 10. So I'm just going to do my working up here. So the height after 10 seconds would be 10 plus 5 sine 10. And you just go to your calculator and you type that in exactly as it reads. Alright, so there's nothing difficult for that. So for me, everyone should be getting that first remark. And you type that in and it gives you an answer of 10.86. So let's just say 10.9 metres. And it says up here that H stood for metres. So after 10 seconds, the Ferris wheel is 10.9 metres off the ground. Then the part B says find the two times during the first turn of the wheel when the carriage is 12.5 metres above the ground. So why they're saying the first turn of the wheel is because there's going to be 2 points when you're 12.5 metres off the ground. You might reach 12.5 metres off the ground on your way up, and then you'll reach 12.5 metres again on the way down. So that's why there's two answers. Think of the beginning of your sine graph. It goes up, then down, all right? And then there would be more answers for when you go in your second rotation and your third rotation. So that's why it's saying the first bit. So literally, they want you to make your height 12.5. So you replace H with 12.5. Now, I'm going to put it the right-hand side so it looks like the format of all other questions. So you do 10 plus 5 sine t equals 12.5 because that's what your height is. Then we rearrange it to be sine t on its own. So we do 5 sine t equals, take away the 10 is 2.5. And then sine t is 2.5 over 5. I'm just going to squeeze that in there. So 2.5 over 5. Now this is positive. So all sine, tan, cos, we're going to use all, and sine. So your acute angle is when you do shift sine of 2.5 divided by 5. So an acute angle, when you do shift sine of 2.5 over 5, gives you an answer of 30. So in quadrant 1, now it's not x today, it's t. So in quadrant 1, t equals just your 30, sorry. And in quadrant 2, t is 180, take away 30. So that's in the sign box. So t equals 150. So my conclusion, my final answer is that is time equals 30 and 150. And I should have really put in seconds in there, but you can see I'm a bit tight, okay? So seconds in there for the end. My second example talks about the depth of water in a harbour. So obviously the tide goes up and down. So the water at the side of a harbour where the boats are would be going up and down throughout the day as well. So in this one it says T is the number of hours after midnight. And it says find the depth at 3 p.m. Now 3 p.m. is 15 hours after midnight, isn't it? Because really that would be written as 1500 hours. So what we do in this one is we replace T with 15. So we say depth equals 14 plus 3 cos 15. You go type that into your calculator and it gives you an answer of 16.89. So let's say 16.9 and it said metres in the question. Part B is a different slant, and they used to ask these years and years ago when I did these questions in my exam, but it's worth always mentioning. Ask for the maximum and minimum depth of the water, and you might think, God, how on earth do I know that? But let's just look at that equation a bit closer. It says 14 plus 3 cos t. I'm going to write that as 3 cos t plus 14, right? And what I want you to think of is this graph here. The graph of 3 cos t looks like this. And it would go from 3 to minus 3. So the maximum height of that graph was 3, but we moved it up 14. So the maximum height of the graph was 17. If I was to draw this, the maximum number would be 17. Now that's what the maximum depth of the water is. Okay, so the maximum depth of the water is 17. Now the minimum height of the graph was negative 3, this lowest number down here. So, but then we moved it up 14. So negative 3 plus 14 is 11. So the minimum depth of the water would be 11 metres. So if it asks about that, it's asking you to picture the graph, and there is nothing wrong with doing a wee sketch of the graph. So it's just a wee twist on it. Third example here is about a person at a lift. So the equation here is the height in metres of the lift above the ground is given by the formula. Because your lift goes up and down all the time, doesn't it? And it says where x is the angle of elevation of the lift from the surveyor at point P. So as he's looking at the lift, so imagine one of these clear perspex lifts that you might see in the shopping centres. If you're looking eye level at it, your angle 0. If you watch that lift go right to the top of the building, your angle will change. And then if the lift comes down, the angle will go down again. So we're talking about an angle going up and down, okay? So this works for the example. Now I'm just going to shift this a wee bit so we can see it. So you've seen the diagram, all right? And we have to trust this as the equation. Sometimes I have no idea where they come up with these equations from, but we have to accept it. So it says, what is the height of the lift above the ground when the angle is 25? So you replace the angle with 25. So you replace x with 25. So for part A, the height is 15 tan 25 plus 1.7. Now that 1.7 is the height of the wee man who's standing watching, right? So when you type that into your calculator, you get an answer of 8.69. So let's say 8.7 metres. So when the man's looking at an angle of 25, the lift is 8.7 metres off the ground. Then it says, what is the angle of elevation at point P when the height of the lift is 18.4? So your height is going to be 18.4. Sorry. So we do 15 tan x plus 1.7 equals 18.4. We're going to move things around. So we're going to move that 1.7 over. 18.4, take away 1.7. Oh, I have to use my calculator for this one. Is 16.7. Please use your calculator because you don't want to make wee mistakes by trying to do things mentally. Then we divide that by 15. And I'm just going to leave it as an ugly looking decimal. Now, I'm running out of space here, so let's move things again a wee bit. I am then going to do x equals the inverse tan of 16.7 over 15. And the acute angle that comes out when you do that is 48, it's the nearest whole number. Now, what I haven't done yet, which I normally do first, is my all sine tan cos table. When I did the equation, it came down to a positive fraction, so I'm using all in tan here. So my all answer would just be x equals 48 degrees. Now my tan answer would be 180 plus 48, but let's think a minute. This gentleman is standing looking at a lift. Is there going to be an answer of an angle of 228? No, because then he'd have to flip his head away backwards. So the second answer isn't actually important here. So we're not using the tan box at all. They only want the first answer of 48 degrees because he can't look at an angle of 228. It's not possible. Another example here about the water in the harbour. At this point, I would maybe say, right, pause the video and try this one for yourself. So go do that, pause it if you want and try it, and then unpause and you'll see me very, very quickly go through the answers now, okay? Right, hours after midnight, so 5 AM is just replacing H with the number 5. So you have your depth equals 3 plus 1.75 sine. Now it's 30 times 5, which is 150. And when you type that in, you should get 3.875. So I'm going to say 3.9 metres. The maximum difference in the depth of the water in the harbour, though this, and it says don't use trial improvement, so this isn't asking you for the depth at a certain time or anything like that, just wants a maximum difference. So this is going to ask you to look at your graph again. So you've really got a 1.75 sine graph that has been moved up 3. The 30h bit doesn't really matter, so I've just rewritten my equation there. So your graph highest number was 1.75, but we've moved up 3. So the maximum is, sorry, I don't know what I'm writing, is 1.75 plus 3, which is 3.75. The minimum is negative 1.75 plus 3, which is 1.25. So the maximum difference is the difference from top to bottom of those two depths. So the difference from 3.75 take away 1.25 is 2.5 metres. Now there was another way to do that. If the maximum of the graph was 1.75 and the minimum was negative 1.75, no matter which way I move this up or down, it's still going to be the same distance apart. So you could get the 2.5 from working out how far it is from 1.75 down to negative 1.75 as well, which gives you a 2.5 metre difference. Okay, so that's that one. Again, here's another one very, very similar. Part A would be subbing in an angle of 60. Part B would be looking for the lowest point on the graph, so it's a negative 23 plus 40. And part C is when you put H equal to the height of 61. So go try, pause, go try it, and then come back and I'll have the answers on the screen for you. Okay, so there's the answers put in. This one again, feel free to go try it and pause it. I'll quickly talk you through what you do here. So for part A, you would calculate the height when at a time of 30. So part A, replace T with 30. Part B, it wants the 2 times when the height is 10.5. So you're going to replace H with 10.5. Pause it, try it, and then press play to check your answers. Okay, so there's your answers. A would be a depth of 10 metres, a height of 10 metres, and B, the times would be after 39 and 141 seconds. And that brings me to the end of this video. I hope you've followed and understood that. I've kind of covered all the different wee variations and twists on these questions. Thanks very much.